Welcome back to another episode of Adventures in Machine Learning. I'm one of your hosts, Michael Burke, and I do machine learning and data engineering at Databricks. And today I'm, of course, joined by my lovely and wonderful co host.
Ben Wilson. I do slide deck presentations at Databricks.
And today we have an amazing guest. His name is Brad. He's focused on software infrastructure throughout his career, and more specifically, he's held leadership roles at a variety of organizations. Some ones that you might have heard of are he was a project lead at Eclipse Shea, which is Eclipse on Kubernetes. He's also a VP and GM at Red Hat, which is an open source software product development organization that specifically focuses on giving that software to enterprises. He's also been the GM of API Gateway. Sorry, let me redo this. My English is not here today for some reason.
English is not Englishing.
Exactly. All right. So we'll leave a note for the editor, but let me start it off again. Today we are speaking with Brad. Throughout his career, he's focused on software infrastructure, and more specifically, he's held leadership roles at Eclipse Shea, where he was the project lead. Eclipse Shea is Eclipse on Kubernetes. He's also been the VP and GM at Red Hat, which is an open source organization focusing on developing open source for enterprises. And then finally, he's been the GM of API Gateway at AWS, which is this, I think it's like a cloud company or something. I think I've heard of them. And then most recently, he's worked at Jozu, which is an MLOps company, and he is the founder and CEO. So, Brad, what differentiates Jozu from all the other MLOps tools out there?
Oh, wow. Yeah, it's a good question. It's a fair question because there's what, 1,000, 10,000 MLOps tools out there right now?
Yeah.
It's like there's about 1,000 new every day. So I'll actually start by talking about KitOps, which is the open source project, because that's kind of where everything started. My last startup, we did a bunch of things with analytics and machine learning. This wasn't like Gen AI type, fancy stuff. These were more standard ML models, I guess you'd call them. But even within that narrowed scope or the smaller scope of those models, having come from 20 years of software engineering, myself and my coworkers were kind of shocked at how kind of kludgy things felt when you're trying to coordinate versions of models with versions of data sets, with versions of parameters, with deployment configs, all these things that you needed to do in order to get a model from a Jupyter notebook into production running, helping customers. And we just thought this seems harder than it needs to be. And we looked at the end-to-end tools, both open source and proprietary, and they definitely helped. But the thing that we didn't love was that all of them seem to have a very proprietary format. And coming from so much of my career being open source, one of the things I feel super strongly about is open standards. Even more than open source, is open standards. I hate it, for example, that there's a different plug and voltage and electricity standard in North America than in Europe, than in Asia, and it seems meaningless, pointlessly different. And so I see so much of that in software that I'm like, let's not do that again. So what we did with KitOps is we said, well, if we were going to take a group of artifacts for something as important as an AI project, we don't want to change the tools people are using in development because those are necessary. They make sense. But when it comes to packaging all that together and then moving that through the development lifecycle and into production, why wouldn't you use something like the OCI standard, which is already used for containers? Pretty much every enterprise in the world uses it as a core part of their pipeline and infrastructure. Now, we didn't want to containerize data sets because that, for example, doesn't really make a lot of sense. You don't gain much by containerizing data sets. You don't want to containerize your parameters. That also doesn't make sense. But interestingly, the OCI spec is actually much broader than just containers. And so we realized you could create an OCI compliant package that was not a container. But I think of it as being kind of like a chest of drawers. There's like a drawer for your model, a drawer for your data sets, a drawer for your parameters, a drawer for your config. You can package all that together and you can say, okay, it's version 6 of my model, version 2 of my data set, version 5 of my parameters. But the whole thing is version 1.2 of my project. So now as a leader, I can say, what version are we at? What's in production? Oh, it's 1.2. What's in development? 1.4. What's in staging? 1.3. Oh, that's interesting. Now I know where kind of everything is. And I don't need to worry about what the subversions of all those individual things are in there. But for a data engineer who's just working on the data sets, they can easily see that. And if they only want to pull down the data set, because they don't need the model, because they don't need the config, they don't need the params, they can do that. So they don't need to haul these giant, 100 megabyte packages back and forth in order to get the convenience of having a unified package. So that was kind of the route that kind of kicked it off for us. And we've been fortunate. We kind of started on this in February of this year, launched 5 weeks later, thanks to just an awesome team of folks I've worked with before who work really fast. And we've already got thousands of downloads, lots of people, some interest from some very large enterprises who are struggling with this problem. So it's been good.
Got it. So just checking if I understand it, you're looking to develop sort of a more modular set of components. That's the pitch.
I would think of it. It's not so much a modular set of components. So the part of why we called it KitOps is because the role that Git plays for traditional software is that it is where you put all the code. It also ends up being the changes to that Git repository are the events that trigger an indication of we're finished development. Now we're into, building and testing. And then now we're into deploying. And now we're into retiring the old thing, which is no longer valuable to us. Git kind of covers that for software, but it doesn't do that very well, at least in our opinion, for serialized models. It doesn't do that very well for huge data sets when you're talking about training like Gen AI, especially. It's kludgy. Yeah, you can use Git LFS, but honestly, it's not fun. Nobody enjoys that. And after a couple of years of making changes to huge data sets like that in a Git repo, the Git repo itself becomes painful. So I think of KitOps as being kind of I hesitate to say replacement, because you would still use Git for your code, of course. But rather than drop your giant data sets and your serialized models in Git as a way to version control it and workflow it, you put that in KitOps. And so you still have that connection between KitOps and Git, for example, between KitOps and MLflow or any other tool, even with KitOps and a Jupyter Notebook, for example. Does that make it clear, Michael?
Yes, crystal clear. What are the types of lineage and versioning features that customers really like and that you guys are focusing on?
So I think, it's nothing particularly innovative. I think, again, the kind of core of what we were trying to do is stick as close to possible with what has been proven to work in enterprises already, because AI is a huge change for enterprises. And we didn't feel like changing every part of the tool chain was a good idea when you've got these big changes happening anyway. Some of them you need to, but some of them you don't. So typically you would still version your code in Git. You could use DVC to version your data sets if you want. But rather than have somebody say, oh, well, which version of the data set goes with which version of the model? Or let's take a really scary scenario. Let's imagine you're an enterprise and you realize that accidentally, shouldn't have happened, somebody managed to put sensitive or PCI data into a data set that trained a model at one point. Now the question comes, okay, which models were trained with that data set? That's actually a really hard question to answer if you've got your models in NVIDIA, your code in Git, your data in DVC. I don't know, I think maybe these based on time frame, but I think based on time frame is not the kind of response you want to have to a compliance question.
Got it. That's super cool. And what type of customer adoption have you seen? Has it been sort of slow and steady? Has it been a lot of the connections maybe so you have an initial sort of uptick and then it's flattened out a bit? What does it look like?
It's been very steady, yeah. And admittedly, we're on, I think, week 8. So I've got to kind of temper that with we'll see how things go in another 8 weeks. But in fact, things have been accelerating. The last 2 weeks straight, we've been setting records for the number of downloads, and each time more than the last. So that's been really exciting. In all honesty, the biggest response we've gotten has tended to be from either DevOps practitioners or MLOps practitioners. Data scientists themselves, I think, get it. And certainly the ones that have worked more with models that have transitioned to production, they seem to really get it. But I think, there's a large portion of the data science community that, for very good reason, they became data scientists. They didn't become, production, dev SREs for a reason. They live in a Jupyter notebook, and a Jupyter notebook is their world, or something similar. And so for them, how do you version this in production, and how you have confidence that, you can roll back to the correct version if there's a problem? That's somebody else's issue, not theirs. So I think it's more those folks who have responsibility for production that are starting to see these things happen, or see them coming down the road, and they're going, ooh, I don't want to be the guy with my hands on the keyboard in production trying to figure out how to roll back to a model when I don't know which versions correspond to what. Like, that is never a good place to be at a bad time.
Yeah. So Ben, I'm curious, what is your take on how this philosophy differs from that of ML Flow?
It's interesting. I looked at the demos of it and I was like, man, this is cool. But when I looked at it and said, man, this is cool and this looks familiar, it wasn't because of work on the ML Flow side. ML Flow, it takes a different approach that is geared more towards the data science crew, and saying, we give you a registry, we give you the ability to tag and version control your models and artifacts, and it's more of a data scientist tool. But for machine learning engineers, exactly as you said, Brad, it's those people that are kind of left in the lurch in industry right now, because there's a lot more data scientists out there, or a lot more people that are creating models, producing them, tracking them properly, than there are people deploying. And a lot of places that I've talked to, like a lot of companies, and even internally at Databricks, it's not, the people doing that aren't the people that a lot of people think are doing that. It's not like, oh, this is a data scientist that has learned how to code, who's now like doing deployments. Like, no, it's a software engineer who doesn't know anything about the ML side of it, because that's not what they did. They're more concerned with, how do I package and deploy software and version it and make sure that I know what I'm pushing to staging. I can't interpret the results from staging. I have to get a data scientist to look at that and be like, is this predicting what you thought it was? So it's like inefficient, and those people generally get frustrated, and they run off and they build their own solution for it. And what I looked at when I was seeing the demo of what you built, I was like, man, this kind of sort of has this feel of like our build tool. So it kind of feels like Bazel, and you're like, okay, I'm building a bunch of container images, and I get all these MD5 checksum hashes from like, here's the conditions of everything that went into this build container that's going to deploy. There's validation steps. I can see the lineage and the history of what went into building this. But it's specifically targeted towards the machine learning engineers out there, which I think it's cool. And I kind of knew, like we were talking about this 2 years ago internally in the team, about like, man, somebody's gonna like go after this and do this right. Like, somebody's gonna take software development best practices and apply this to the MLE side. It's just cool. Like, great job on your company working on this.
Thank you, Ben. That's great to hear. And I think it's something that we've heard from others. I was speaking to a data engineer at a big recreation-focused software company that everyone would know. It starts with a Z. And they were basically saying that the development process for them around the AI-specific side of what they do was a bit of a struggle. Not on purpose, but it was just that there was the AI team that really, really understood the model, but didn't really understand production. And there was a production software team that really, really understood production, but did not really understand models, which are not deterministic. And you think about like the core of everything you learn about data science is determinism. There is no like, let's deal with this totally non-deterministic system now. That's not like something that people spend a lot of time on in most computer science stuff. So it's a weird world. And, he said, like, this is really, you're creating a middle ground now, a place where the AI team can work and the software teams can work, and they can actually understand each other. They can use a single relatively simple tool and kind of get something out of it. And I think that was really nice to hear, because that was exactly what we had wanted to do. It's always nice when you hear people kind of seeing things that way.
And why do you think you guys were some of the first people to tackle this in a seemingly correct way? Is it hard? Is it just the stars aligned?
I think some of it is hard, but it's not. This is not like this is not like building the first Gen AI. It's not hard. Like, the hardness is not the big thing here. I think that the big thing here is that myself and the co-founders, we've each got 15, 20 years of experience building dev tools and DevOps tools. We've spent time in some of those big organizations like AWS, like Red Hat, like Docker. And so we're really, really familiar with the way that enterprises process products. And I think it's funny. My father was the head of research and development for Nabisco Brands. And so growing up, he would bring home these cardboard boxes, unmarked cardboard boxes of cookies or cereals that were tests that they would develop in the test kitchen. And we would do A/B tests when I was a little kid. And he'd say, like, which one of these, jam-filled shreddies do you like, or shredded wheat do you like better than the other one? And for him, because he was kind of on that sciencey side, that research side, once they had kind of chosen the product, he's like, it's done. But reality is that was just the start. Like, that's still just a brown box with no name and some hopefully delicious thing inside. It had to go through massive amounts of like market testing and branding and positioning and where the shelf space is going to go. Whose shelf space do we steal to put this new cereal in the grocery store? And I think of it's the same way, that you have a lot of strong, very smart researchers and technologists in the AI ML world right now. Super smart people, some of the smartest people around, all working together on these problems, which is why you see AI growing so fast. But most of those folks are not familiar with that whole 70% that comes after you found the great model. We lived in that world of the 70%, but had spent so much of our time focused on the new and the innovative. I mean, my CTO worked with Kubernetes very, very early. 2 startups ago, great friend of mine, Tyler Jewell, who now runs CEO for Lightbend. He had a web IDE company that he'd started and saw containers in 2014, I think, maybe 2015, and said, we should make these the basis for all of our web IDEs. And so I joined him and we tried to do it, and it was a nightmare. Containers were not super stable, and trying to run thousands of them at the same time for something like a web IDE where responsiveness has to be instantaneous, or people are just like, this is a waste of time. Man, that was hard. So hard. And so, but we got there and we sold the company to Red Hat, and it was amazing. And you realize that, like, sometimes you just need to understand that enterprise world and then look for the new things that are not really mature enough and figure out how to make them mature enough to fit into the enterprise world. And that's really what we're trying to do with KitOps and Jozu.
That's fascinating. Can you dig a little bit deeper about what that, for lack of a better word, productionizing a feature is? So it's built, you've A/B tested it, you know that the shredded wheat tastes amazing. How do you go about adding the label onto the box and then doing all those additional steps that you mentioned to ensure that it's a scalable product that many people will use? Is there a formula? Are there steps? How do you think about it?
It depends a little bit on what the industry is and what the product is, of course. To bring it back to this particular podcast, though, rather than food, which actually, to be honest, I don't know as much about, other than deliciousness. You look at a model, and some of the things that we struggled with certainly were, how are you going to test it? How are you going to test it and validate it before it goes out to make it? And then, now the good news is that there's more and more tools that allow you to do this, including MLflow. But then you've got to figure out, okay, how are we going to log it? What's the right data to log? How are we going to identify where a problem is coming from? What are the signals that would tell us that we need to roll back to an older version of the model versus those signals that tell us that, no, we've just got to figure out a way to shape traffic or do other things to kind of give the model a break or better balance things with the model? How do we handle drift? And at what point does drift become bad enough, again, to say we need the new model tomorrow to correct this, or no, we'll do something else. At AWS, it was amazing for me working with API Gateway, because API Gateway's success is not about features. And being someone who spent a lot of my time in product management, you get so used to this idea that you grow, your product grows because you add features. And the more features you add, the more growth you have. And it's the biggest fallacy in all of PM. And I fight it in every one of my organizations whenever I have a chance. And I saw no better proof of that than API Gateway. It had less features than probably most of the other gateways out there. And I don't think they would argue with me. I'm sure most people wouldn't. But it was wildly successful. I mean, it's a 9-figure business on its own. And that's because it does the hard stuff of that 70% really, really well. You can scale it massively. You can shrink it massively. You can do those things repeatedly and incredibly small amounts of time. It is super secure. Like, you can imagine the constant stream of attacks and other black hat initiatives that were being put against API Gateway every single day. It's the face of AWS. And the product was bulletproof from that perspective. And so you think about those things in terms of models, it's not different. Like, you put a model out there, you've got to be able to protect it. You've got to be able to scale it. And scaling doesn't just mean going up. Scaling means kind of coming down. How are you going to, can you horizontally scale it? Or does it have to be vertically scaled? These are all questions that need to be answered and dictate a different way that you have to test it, that you have to deploy it, that you have to manage it and operate it, that you have to maintain it, etc.
What's your market research strategy like? Do you go and interview people? Do you go and just put it out there, see what happens?
Yeah, great question. So I guess it's a bit of both. I'm a big believer in nothing tells you more than getting the thing out there. You can talk to people until you and they are both blue in the face, and you might get to the truth. You might not. Not because people are lying to you, but just because there's no truth like usage. That is the ultimate truth. If I use something, I need it. If I think I need it, but I never actually use it, and we all have these, you're just looking around your own house. If you were to move tomorrow, there's probably boxes of things that you would be able to leave behind and you might not even remember. So to me, in some ways, it's not even about purchase, because people purchase things they don't need, but no one uses something they don't need. That just doesn't happen. We don't have time in our days for that. So usage to me is the ultimate. I always start by, yes, asking lots of people, and specifically asking people who are at the edges of what I think are my user base. So obviously you got to talk to the core of the user base. Like, for example, those DevOps folks that have been a bit alienated. That's key, of course. But once you kind of get enough head nodding from those folks, now you got to talk to the folks a little bit on the outside. Like, is the product manager going to care about this? Is the tester going to care about this? Is the ML engineer going to care about this? And is the data scientist going to care about this? If you get enough kind of good signals from that, then you create the thing, you push it out, and ultimately that's where you really, really learn. Code Envy was fascinating with the web IDE, because we built it. It was also, in addition to being the first one that used containers under the hood, it was also, if not the first, certainly one of the first that could actually do compiled languages. Back in 2015, web IDs pretty much only did interpreted languages. And so we built it very purposely to do compiled languages, because we said, well, Java is the biggest language at the time in enterprises. It's compiled. All the languages, frankly, that were used in enterprises were compiled at the time. And so this will be an enterprise tool. We use it, sell it to enterprise teams building software. That's how we're going to be successful. Absolutely. And then it did very well, but not amazingly. And we noticed a couple IoT engineers, embedded systems guys, using it. We were like, huh, that's weird. And so called them up and talked to them about it. And they were like, oh, yeah, it's a nightmare trying to configure 5, 6, 7 different embedded system platforms, VMs or containers, doesn't matter, on my laptop. That's annoying. It's hard. It's frustrating. The fact that I can do this in the cloud now with your IDE is amazing. I'm so much more productive. Tyler, myself, no one who founded the company ever had any idea about these use cases because none of us had ever worked in embedded systems or IoT. But as soon as that person said that, I was like, ooh, this makes a lot of sense. Shortly thereafter, Samsung was our biggest customer, and it was for all their embedded system stuff. We would never have thought to go after Samsung, or at least that division, with something like this, had we not had that outcome. And that was about usage. We just followed the usage.
Interesting. That makes sense. Ben, I'm curious how this correlates or doesn't correlate to the ML flow philosophy, because I know you guys like shipping things and seeing if they stick. What are your thoughts?
We're no different. I mean, anybody who has read all the books and has learned over time about product management and takes it kind of seriously, then they say the same thing that Brad just said. Just like, don't fool yourself into thinking that, hey, I talked to 50 people. They all say this is a really good idea. Let's sink in 6 months of work and 80 people's time into this. It's not a good idea. Or using your gut instinct. It's all about ship something. If you have a greenfield idea that you want to test out, take 2 people in 5-6 weeks, build a prototype that you can ship out there, market as experimental, whatever. And yeah, talk to people, get their feedback. But while you're talking to them, your system had better be monitoring how many times they're calling your APIs. We don't collect PII data about any of that stuff. I have no idea who it is that's using it. I'm just getting an integer increment every time somebody hits the API. So I can track over time and say, whoa, like we thought this was kind of okay and useful. Why are there 13,000 people using this a day? Are we onto something here? And then you double down and continue to collect data. Well, verify that you're collecting the correct data, and then it's not a false signal. And then that's how you kind of get directional information about where to go. But yeah, I've seen it many times in previous companies where idea people are just, they're so certain that what they're building, whether it be in the ML space or the pure software space or just the product space in general at a company, they really convince themselves that their idea is great. And then they launch it. And then you look and collect data after the fact. You're like, oh, sales didn't go up the way we did. Let's check on engagement now. Pull the data. Like, we don't have instrumentation set up. Like, why wasn't this thought of earlier? And it's a scramble to say, like, then you get the C-suite involved who are saying, did we just waste a ton of money and time on this? Who's to blame? Like, think about instrumentation and data collection before you build anything, and it sets you up for success, I think.
I couldn't agree more, Ben. And it's interesting because it's one of the things that is hardest. I love open source software, but I think the instrumentation is one of the hardest parts about open source software. I think it's getting better now, but it's really only been in the last few years that I think open source communities have become a little bit more comfortable with the idea that anonymous tracking, that kind of instrumentation, is okay inside of an open source project. I remember it was, now mind you, I'm getting old. It was probably, it doesn't feel long ago. It was maybe, 8-10 years ago, where we had to fight to add that kind of data to the early versions of Eclipse because people didn't like it. They just were like, it's open source. It shouldn't have that stuff in it. Even though it was visible to everybody, didn't matter. But that stuff is critical.
Yeah, for open source and ML Flow, we don't do that. We look at download statistics to just kind of get a general idea, and we talk to open source, specific users in open source that happen to be Databricks customers. But They don't want to use the Databricks managed offering. They built their own. Like,
Mhm.
hey, we're running MLflow on Kubernetes with, 600 pods because we have, 8,000 models being built a day. And we're like, whoa, that's crazy. You can do that on Databricks. They're like, yeah, but we have to integrate with all these other systems, so we need to modify MLflow. Like, cool, yeah, that's what it's there for. It's open source. Do you need any tips on what to do? And we love working with them because we get information and we want to
Yeah.
know what features are you using. But on the Databricks side, that's where we collect telemetry. So we know every single API. We don't collect any data about what they're doing with it or who they are, but we can see every 10 minutes we can see a window snapshot of like what APIs are being hit on anything involving MLflow, and you can track over time by region globally. It's interesting things sometimes. Like, you look and you're like, all right, we're down to the last 5% of countries on the planet where people haven't used this particular API, and you just see what resonates with people. And looking at your product, uh, it it really brings to mind a lot of issues that I've seen in us internally doing, like, building demos and something, or doing stuff within internal teams where everything's, when you look at ML ops through rose-colored glasses, you're like, okay, I'm doing a happy path, which a lot of people like to focus on, which is, okay, I get my data set, I did all my statistical validation, I've done my feature engineering, I've got this data set, it's versioned, I've got everything set, I've cleaned it, PII data, whatever I needed to do. And now I want to go into model tuning and hyperparameter tuning, and I generate this artifact that I can use to run predictions. I do all that. When you're doing the first deployment, it's relatively easy. When you're doing the 7th deployment, it's relatively easy, provided you never had to roll back. And what you said earlier in the talk really resonated with me, because I've had to do that back when I was a data scientist / MLE in previous life. Was, okay, we just deployed something that's totally broken because we didn't even know that this was a problem. We didn't have tests for this because everything was compartmentalized. We had
Mhm.
data set, data engineering style quality checks, and then we had ML, like, verify the predictions, and, like you said, non-deterministic results. So doing statistical validations of, are we like classifying stuff to the right proportions? Is our regression results within these bounds of SPC? And then you go and do quality checks, unit tests and integration tests with the deployment side of the house. But there's nothing that had everything built into one artifact that you deploy to a system to say, here's all of the stuff that I'm doing to each of these different systems, and then test it end to end. That was always manual. In your first 5 or so deployments, you're really scrutinizing everything of that step of, like, hey, I'm manually checking these 10,000 results that I ran through for validation, and just making sure, because I'm scared, like, is this junk or not? And then running through statistical validation of the outputs and saying, okay, we're good. We can flip the switch, or we can transfer traffic over to that. It's good. And then slowly, monitor it. And then people are looking in real time at data coming back and making sure, like, yeah, sales are up, or like engagement's up. We're good. Let's flip the switch. But when you get to like the 37th release, 10 months after you started that project, and everything has kind of gone well up until that point, you find a huge issue in your deployment. You realize, I think this has been around for like at least 7 weeks now. What state do we go back to restore and get, like, avoid this problem? And now you waste 2 weeks, or sometimes, like, personally, I've had to shut off a system that is making the company money in order to scramble to rebuild a previous known last good state. And that's all manual. And you're like on hour 53 nonstop without sleep, and your 17th cup of coffee, you're wishing that you had something that had, like, why are we not building containers here, or something where I can have, like, a build manifest that I can just say, yes, is a known last good state. So it's cool that you guys are solving this. It is a fundamentally massive problem for everybody involved and for a company.
Yeah, I think that's the thing, and I couldn't agree with you more, Ben. I think you haven't actually operated a service until you've had to roll back the broken service. Like that's the point at which you've finally operated the service. Up until then, it's like riding a bike downhill. Like, sure, how hard is that?
Yep.
Then you come to go up the hill and you're like, oh wait, this is a lot harder than I thought. I'm actually not as fit as I thought. So yeah, no, that's exactly it. And I think that the company risks are often and sometimes because they're unknown, but kind of underappreciated by the folks working in those roles. I was speaking to a major global retailer, and this is quite a few years ago now because they've been using AI for a long time. But they had a group of data scientists who built a model to predict the different types of clothing that should be distributed to warehouses in different regions and locations based on what clothing was popular in each of those areas. And it was very, very good. It worked extremely well. And as you can imagine, it's really important for the thin profit margins of these kinds of companies to get that right. Because the more inventory they hold that isn't sold, that's just lost money. So first year or so it was out, fantastic. Now, part of the problem was that the data science team that had built it didn't have any responsibility for it in production. The engineering team that had taken what the data science had built and kind of built it into a service that was actually usable by a customer. Because generally, it's not like a customer can just send an API request to the model. Like you have to have a set of services that kind of broker between what the customer is trying to accomplish and the model. And so the software engineers built that and built the plugs into the model. And so they owned that front end system, but they didn't know anything about how the model worked. And so they didn't feel ownership about the model either. Well, the model started to drift and its recommendations got worse and worse and worse. And it snowballed. And this happened, unfortunately, kind of during the pandemic when maybe people's eyes were not quite as on the ball as they would otherwise have been. But it ended up being actively bad for their business after a couple of years. And everyone is looking everywhere else and the fingers are pointing in all the different directions. And that's the stuff that's scary. And you realize that sometimes when I'm talking to people and I say, like, this is going to give you a central way to track and control your AI projects from an operational standpoint, they're like, okay, that sounds nice. But I'm like, I don't think you understand how critical this is.
Yeah.
You will, the day you recognize how critical this is, you will really, really wish you could come back in time to this conversation and go, oh yeah, well, no, we need to do this now. Because it will be too late then. And it will hurt. And this is exactly what this particular company got to, is they were like, wow, we've lost untold millions of dollars because we didn't know where the thing was and how to roll back and where the good version was and where the bad version was. All those things, they're not the things that most people think about first.
And that's the sort of wisdom, like Michael and I have talked about it on the podcast a couple of times and in private as well, because he's very curious about software development, as he should be. But some of the bits of, wisdom that I've given him, it's never the rosy fun stuff. Like, oh, you get to build this super cool feature and it's really exciting. We never talk about that, do we, Michael? We always talk about.
You're always complaining.
Yeah, I mean that's the role, really, is like, hey, don't think that this is. I mean, it is exciting, and you are building cool stuff, but you're also knowing that it's what happens after it's built that matters way more. And there's nothing like that sinking feeling of you realize that you didn't write enough tests or you didn't validate something or some sub-zero regression got shipped and now you're in recovery mode. And it's a learning experience, and it teaches the team and the organization new skills on how to recover from calamity, and it's going to happen. The only people that don't experience it are people that are, in the basement building their models and hoping that someday it'll be used for by the business, which I think a lot of that is still present in the ML community. I think people are, oh, this is a really cool project that the data science team is going to work on, and it does this really neat thing with AI. I was on teams that did stuff like that. I built things like that. Like, it'd be really cool if we did this, and built it, show it off, and people were like, that's amazing. And then you got one person, like some principal software engineer, after it comes up and be like, how are you going to ship that to prod? I'm like, I don't know. Let's not talk about that right now. That's next quarter. And they're like, come talk to me. Let's plan this out. And you learn from people, and then you really learn by messing it up. And that whole, like, ship something, have it break, panic, fix it. It teaches you how important all of this stuff is, and that ability to recover. I imagine, I don't know if I haven't really dug into your tool yet, so I apologize for that, but automatic rollback of something like, hey, I can flip a switch in either a UI or through the command line to say restore last known good version. That, I think that was built 3.5 years ago at Databricks, where it's an automated system now, where like full integration tests that are done in, through container validation and integration tests. If that pre-built in staging environment fails, or if a region ship, like we deploy code to regions like AWS regions or Azure regions, if something fails there before that gets switched on for customer usage, some like image of our platform, it'll just automatically go to last known good. You get a lot of pages when that happens, to let you know, like, time to update your tests, or fix your build process. But it becomes so critical, because if you don't do that, the manual recovery process, you could wipe out hundreds, if not thousands, of human hours with just one regression if you don't have anything set up. So I see tools like this becoming more and more the mainstream for people that are serious about actually shipping their basement projects.
Yeah, and that's and I think, interestingly, Ben, you've given me kind of the perfect segue from KitOps to Jozu. So, I mean, KitOps is very much focused on that packaging and the versioning and that single source of truth, and being able to get people to, yes, use whatever tool you want, because your tools are important to you, but this should be the location where is the canonical, that's where the project is. And all the tools can pull from it, all the tools can push to it, but we know. And you have your tags there for, champion, challenger, latest, stable, whatever makes sense for you in your process. Jozu is going to be much more of a kind of control plane for AI projects, is how I think of it, which is a nerdy way of saying it, perhaps. But you think about operationally, there are so many of those steps that you outlined, Ben, and that I know you've been involved personally in. And the way that those get done needs to be standardized. One of the things that I really, really took away from AWS was there was this strong focus on mechanisms, which was really just a fancy word for process. But it had to be automated. And so people would relentlessly go and kind of pick away at anything where humans had to make a decision and say, do we need the human to make the decision, or can we do something automated so that in the pressure of a moment when everything is happening is going wrong, where there's fires all around you, you're not waiting for somebody to make a decision at a time when their decision-making capacity is going to be compromised. And so you think about a control plane as having a way to encode all those good decisions. And like you said, you're going to get pages when the tests fail and it rolls back automatically to the last good version. But at least it rolled back automatically to the last good version. Didn't push forward with the bad one. Like, that's a way worse scenario to have. Oh, yeah. I once had a junior engineer who made one mistake in coding some deployment code and ended up taking out an entire region for only about 5 minutes. But it was it was scary. And it was a good life lesson in this is why we encode things, not, do it manually. And they've since gone on to be an awesome engineer within AWS, but it was a fun start.
Yeah, I'm curious. Do you get more of an understanding of how serious things can be because of working at the companies that you have worked at? Because I can't imagine table stakes being higher for anybody more than those two companies that you mentioned, Red Hat and AWS. I mean, more than half the internet runs on both of those companies. I mean, you're talking trillions of dollars in the global economy. So you can't really ship, it looks good enough, a version of Linux or something that enterprises use. Or, if some sort of CVE gets issued and you just don't respond to it, don't fix it, don't ship out a build. It's more than just money for that company. It's reputation. It's like, hey, this is the safe and secure place to run your code. Did you absorb all of that rigor around how to properly deploy and manage versions of code, like based on just being there?
I think that was a hugely important learning experience, and it's part of why I really have always wanted to work at AWS, and why it was important to me that in my career I spent time there, because I've always respected culturally. I think we all kind of are taught through media and everything else that it's the idea person that is the thing. Like Steve Jobs was amazing because he came up with the idea of the iPhone. Well, the iPhone wasn't a unique idea, really. There had been other attempts at it. It was actually just operationally far better than anything else before. And that's how I look at it anyway. And so when I look at AWS, they didn't, I mean, you can argue about whether they invented cloud computing or not, but certainly they have proven year in, year out to be the best at operating cloud environments. And getting a chance to run API Gateway, it was a privilege because you got to see that firsthand. Like it really melted my mind, probably like the first day when I took on and we had a Sev 2 issue at about 2:00 in the morning. And I'm paged. I jump on. I don't know much about the system yet because it is day one for me. One of my engineering managers on. She's amazing. Thankfully, she was on, and we talked through this issue, and we were in a rough spot. To fix our problem would have meant breaking a downstream service. And so we had a choice. Are we going to break the downstream service, or are we going to continue to degrade API Gateway for everybody else? And as we were trying to diagnose this, one of the things I asked was, well, have we done any recent deployments? And she kind of paused, and she's like, well, we're always deploying. And I was like, what do you mean you're always deploying? And she's like, there is always something deploying in API Gateway somewhere. Like it's literally nonstop. Mm-hmm. And you don't think about that. You don't think about the idea that this could require literally 24/7 deployments to be happening in order for you to get all these things out. And so I think, there's nothing that can prepare you to, for that kind of scale. And it does force it deep into your bones because of how deeply you have to think about it. Red Hat was very different. Red Hat, of course, didn't have that immediacy because you ship enterprise Linux and people download it and then they install it and then they run it. It had a different challenge, which was that where AWS, like any cloud company, I mean, mistakes will get made and then you fix them in the moment and you measure your outages in terms of, minutes or hours if you're unlucky. Red Hat was different. I mean, it takes time to build a RHEL image. Even a RHEL patch takes time. And one of the things that I loved about Red Hat, which is they would really only productize a product, at least certainly when I was there, I imagine it's still true, if they had committers in that open source project. Because if there was a CVE that came in, they needed to know that they had full autonomy to fix that CVE and deploy that patch as quickly as they wanted to do it. They never wanted to be in a position where they had to wait on some other committer with an unknown schedule and an unknown set of priorities to merge a fix for a problem that was critical to their customer base.
Mm-hmm.
You've got to own that ability to help your customer. If you can't own that, then you should not be in the business. And that was really what hit me, because that's not a given in open source. There's actually, and probably, this doesn't happen so much now, but certainly back then, there were tons of open source based companies that didn't have committers and couldn't directly control the pace at which a security issue went out. And Red Hat, in doing that, really made themselves unique, and that's why they're so trusted even today.
Were there any practices or cultural elements that you have tried to avoid that you saw at AWS or Red Hat?
Yeah, there's always things that you kind of don't agree with. I don't think that there were any systemic things, though. Some of it just comes down to kind of personal approach. And a lot of it has to do with the scale. In my companies, I've always believed in being extremely transparent with the rest of the team, and not just the exec team. I mean, everybody. I talk to my team about the highs and lows of fundraising and where our finances are and what's going on legally or anything else. That is risky. It is actually like it can pose a risk to the business to do that. And so in a company,
why?
Well, because people can share that information even though it is confidential. People can panic about the information and not share their panic with you. So you may not realize that the way you've said something came across much scarier to somebody else than it is to you, because you have a lot of context and it's not that scary. But maybe for them, they hear it and they're thinking, oh my God, we're going to be bankrupt tomorrow. And that's not what that meant, but you don't know that. And if they don't tell you, how can you know? And so it's a double-edged sword. I have lost good people because they have gotten the wrong impression about things and thought that they were in a risky position when they weren't, and left to go somewhere else. And that's unfortunate. It hasn't happened very often. But I believe it creates a level of trust. And I think that one of the things that I saw within my team in API Gateway, and I can't speak to others within AWS, it could be very different, but within my team in API Gateway, we developed a great deal of trust in each other. And it meant that we were able to work in those Sev 2 production out type scenarios much more efficiently, because everyone understood that if they say, Bob, can you do this? That Bob was going to get it done. Janet, can you do that? Janet's going to get it done. And if they need help, they're going to ask for help, which is one of the most important things, because a lot of times people think they got to do it on their own. And if they just asked for help, it could have gotten it done so much faster and easier. But again, to create that trust, sometimes you got to share a lot, and it's not possible. It's not responsible to share to that same degree in AWS, which ultimately was part of why I left. Not because they silenced me or anything like that. It wasn't like that. They were awesome. It's really just that I realized that I couldn't be the kind of leader that I like being and be legally and fiscally responsible within AWS. And you should never be in a role if you can't do both of those things at the same time. So that was kind of part of what made me realize, now I want to go back to the startup world where I can kind of put my arms around the whole team, if you will, and kind of make things happen that way.
And do you hire for people with a potentially higher risk tolerance?
So it's interesting. There's a perception that I disagree with slightly, that startups are riskier than non-startups. I think they are very different. It's just different types of risk. And it comes down to what your personal kind of comfort level is with different types of risks. Within a startup, partly, and again, startups are different than, from place to place, but certainly in my startups, when we hire somebody new, everybody is aware that we're doing it. Everybody has access to look at the LinkedIn profiles of the people who are applying, and everybody is welcome and encouraged to provide any feedback. Either this looks awesome, this person looks amazing, or ooh, why, what? Those kind of questions too. We try and have people, as many people as possible from across different areas, participate in the interview process. What that means is that I tell people the level of risk that you're going to get a crappy teammate or an a-hole boss is really, really low because you are an active participant in hiring them. In a big company, that risk is actually really high. In my experience, because in big companies, hiring tends to be made optimized for efficiency. And that means small loops with a small number of people given a lot of power and typically not a lot of cross team, input, anything like that. So you get that risk, but you trade, yes, startups have a certain amount of money. And if they can't generate more of it, then they go bankrupt. And there are more startups that go bankrupt than big companies, but big companies go bankrupt too. So, it just depends on what kind of risks you are willing to take.
That's a good way to put it. Yeah, it's been interesting. I've been at Databricks for about 2 years, and even I don't know the growth and number of employees, but it's been big, especially in the field engineering space. And no comment directly on quality, but I've seen hiring practices have shifted a bit, and it's been the loop has been a bit more concise, and there's pros and cons to that, of course.
No, that's exactly it. And so I think that's, it just comes down to what people want in their career and their life, and that's reasonable.
Yeah. Cool. Well, that was a nice little closing topic. So with that, I will wrap and summarize. Lots of really cool topics today. A few things that stuck out to me is adding features does not always lead to growth. If you want to do something really well, that can often be the most effective path to getting users. Another great way to develop features is just put it out there. See if it sticks. See if there's actual usage. Purchasing is not always a great indicator of whether there's actually value within that feature. And then when you're doing market research, ensure you have a representative sample of your user base, and also think about the tails of the distribution, not just your target user. When things are going down, you probably want to have as many decisions automated as possible. So try to create infrastructure where decisions are automated. And yeah, lots of other things. So if you want to re-listen, definitely do that. There are a few other things that I wanted to discuss, but unfortunately we didn't have time. So maybe next time. So Brad, if people want to learn more about you, Jozu, or KitOps, where should they go?
Now, KitOps, you can go to kitops.ml or look for KitOps on GitHub, of course. You can just visit the repo. Jozu is at jozu.com, jozu.com. It's actually Japanese for something which is skillful or very well done. So that's where you can find those, and you can find me on LinkedIn. I think I'm the only Brad Micklea because I think it's a last name that was probably made up when my ancestors came to this country. So
nice, cool. All right. Well, until next time, it's been Michael Burke and my co-host
Ben Wilson.
And have a good day, everyone.
We'll catch you next time.